Sure.
So everybody, welcome to the Professional VMware VCAP5 DCD. This is session number 3 of the VCAP5 So if you missed the previous ones, just head on over to Professional VMware or watch your iTunes feed. iTunes, you can search for Professional VMware and VBrownBag and you'll find the feeds on there. Both for this, the VMware Certified Advanced Professional 5 Data Center Design brown bags, but also the VCP5 brown bags. And if you're in those last 2 weeks before you need to do your VCP5 exam, because you're a VCP4 and you don't want to do the 2-day What's New training course, good luck and good study. Now, tonight's subject is network design, and great pleasure to have Wee Tan from Singapore office of VMware to come in and lead this session. So, Wee, can you just introduce yourself, tell us who and where you're at, and we'll head straight into the material. Anybody who's got questions, please do use the hand up in the session, and we can unmute you then.
Hi everyone, this is Wee Kiong. Okay, I'm based in Singapore. I just joined VMware for a couple months now. All right. Previously, I was actually doing all the post-sales. All right. Before I just start, furthermore of myself, if you have any questions, you can actually just drop me an email if you have. All right. Next slide, please, Alessia. Okay, just a bit of myself. I've been doing virtualization for delivery services for about 4 years. For now, yep. Previously was in IBM and followed by BT. Okay, I specialize in x86 implementation, including that's for Microsoft backup solutions from Symantec and IBM TSM, and as well for VMware integrations. So I just joined VMware on the 27th. That's about more than a month. I hold certain certifications. CCNA a bit expired, so do excuse me if I couldn't answer too in-depth of the network portions, but I will cover as much as I can on the necessary on the vSphere level. I also blog. You can actually catch my blog. I do some sharing of keeping documented experience or learnings that I have through my blogs, and use it as a sharing basis as well. Intending to do my VCDX for VCDX4. I hope I can complete that. Just out of leisure, I do jogs. I took part in marathons. More of an outdoor person. Okay, so next slide, please. Okay, so today is the agenda. So I just briefly go through the agenda. We'll talk about the requirements, what kind of requirements we're looking at in terms of when you design the vSphere design. In terms of network, what kind of requirements we are looking at, what are the needs and what are the wants. Then we follow on looking through virtual standard switches. So what's there for VSS in short, and what are pros and cons, and including virtual distributed switches as well. And what are the consideration in design, and when you do NIC teaming, what are the things to take note of, what are parameters that are available in vSphere, and why you choose certain parameters. Then we'll talk about VLANs, the logical subnetting for VLANs. We'll talk about also private VLANs that only available when you are using distributed switches, and a short one on Cisco Nexus 1000V advantages. And I'll go into the new features in vSphere 5, including the network I/O control and resource pool, and something about the security, and we'll just do some summary about that. Okay, so as we go along, I will just stop and ask. If you have any questions, please feel free to actually just post them. I'll try to answer them as much as I can. All right. Okay. So requirements on the network design. First, we'll go through the environments. We need to analyze what's the customer environments. What kind of equipment they're actually using, the network switches and routers that they have in their environments. And the type of connections, whether it's 1 GB, 10 GB, or even the new 40 GB, especially for new environments where customers are actually building a new data center, they might buy the latest or greatest network equipment where 40 GB is actually releasing soon. And the bandwidth across site, if they have actually site-to-site design in terms of disaster recovery using SRM, is there a latency available? Any latency to take care of for intra-site, or even for vMotion if you are doing a metro clusters. So these are the things that you might have to take note of, knowing of the customer environment. So we talk about the network design. We also talk about availability. What are the mission critical systems that they requires for recovery time? The SLAs that you're supposed to meet. The cost also for them willing to spend if they're going to set up this vSphere environment. Is there any added network device that you actually want requires them to purchase if they have they are not going to use their existing switches, or even so, if their existing switches is not able to cater to your design, are they able to actually fork out the cost to spend, okay, to even to upgrade their routers and switches? And in terms of design, we are supposed to also do for scalability. Is your requirement cater for growth? Is there ability to cater for scaling for your vSphere infrastructure? So is this a small environment just for test and dev, or is this actually a production that they're going to move in phases by phases? Okay. Next. Okay, next we will talk about the physical NICs. So for each of the network that is catered, do we actually take care of availability and or redundancy in terms of controller redundancy? So for redundancy, at least 2 NICs per network. All right, that's for ability and redundancy purposes. So multiple networks, you can be sharing 3 or more NICs if possible. So example, if you have a 10 GB link, you could be sharing multiple networks on several uplinks or NIC ports for a 10 GB link, and through VLANs or even ports. And the requirement for customer where backup is, if for example I have certain customers, just taking this as a scenario, I have customers who treat backup as not critical, so they do not need multiple NICs. So they actually request 1 NIC is enough. All right, because the backup could be just for development environment. So controller redundancy on board versus the expansion. So when you do NIC teaming to cater for the redundancy, do you actually do 2 NICs, 2 port groups on the same controller, meaning on board, or 1 on board and 1 from the expansion card? So we also take care, beside the NIC port redundancy, we also take part of the controller redundancy. Alright, so auto negotiation setting. Alright, this is normally we leave it by default to be enabled, because this actually leads to less troubleshooting requirements, especially when you are setting up for fixed bandwidth. So certain customer actually sets like maybe 1 GB link, a fixed bandwidth, and you have to set it on the NIC level, even the switch port level. And in terms of troubleshooting, it's really difficult, and this makes it a long process when you hit any problems. So auto negotiate is normally the most recommended setting that we recommend. So you just have to take care from ESX all the way to the network layer. All right. And okay, and for the best practice on network, you can actually refer to the virtual networking concept information guide, which you can actually download from VMware website. All right, and the NIC cards to support features. For the NIC cards, what are the things that you have to take note of? Does the NIC cards actually support checksum offload? I think most of the network cards nowadays actually have all these features. So, however, you might just take it as for info cases, because all this can be actually offload to the physical NIC cards, especially for the TCP segment offloading features that's now available on the NIC cards. So less CPU cycles will be required when you perform a vMotion and stuff like that. Alright. And for VC motion NIC, you might have to support wait on LAN. All right, especially if you have distributed power management, in short DPM configured. All right, and for jumbo frames, if you need that requirements, it's best to have jumbo frames supported on the network card.
Waitek, can you circle back to auto negotiation? So I've got a question from Jason Yo in Singapore about auto negotiation, and his experience and mine also is that there are quite a lot of environments where there is statically configured ports. Can you run through what the issues are around that?
Okay, because if you actually do static configuration like 1 GB across your switch port, your router's port, and even your ESX port, sometimes when your administrator takes over, hand in hand, they change the head counts. You know, someone who actually set up this environment left the environment, and the next person will take over. And when they do scale, they scale out their environment and they added more ESX servers. They are not aware of this. Settings been in place, all the fixed bandwidth that is in place, and he actually leaves the default setting like auto negotiation, and he couldn't get the connection up and running, and it keep going down. Yeah, this is some of the cases that we actually encounter. Yeah, one of which is a proper handover of all the documentation. Yeah, so in your design, it will be good that you state this very clearly. So whoever is going to take over the environment, you will be, able to actually take note from the documentation that was provided.
Right. And I think part of Jason's question was about how do we handle the customer where that IT staff member who hard sets things is still there and is still saying it should be hard set. Do we have any strong arguments about why we believe it should be auto-negotiated?
In this case, if customer preference is to be fixed, we have to tell them the caveats having the fix, right? We want, to reduce the troubleshooting time. If any of this case were to happen, we actually can mitigate this much easier. But however, if customer insists on having the fixed bandwidth, then we just have to state that in advance. To them that there's certain risks, in terms of troubleshooting in future, if you were to miss out any of the settings, even in the physical switch port level, you see.
Yeah, and I think my experience has been it is consistency is the single most important thing.
Yes, exactly.
But auto-negotiate tends to be, or the preference for hard setting everything tends to come from a legacy environment where you've had nightmares with 10100 NICs, less relevant for gig. Now, I've got another question come through from Karthik, who is asking about jumbo frames. I believe you'll have jumbo frames a little later in the discussion?
Yes, that's correct. We will talk about jumbo frame later in the design consideration.
Okay. So we'll hold off until you're ready for that one then.
Sure. Okay, next. Okay. So on the physical switch configuration, so we have to cater for physical switches redundancy as well. So for the different, like for example, every single port group, you actually have 2 NICs. So each NIC's uplink could be actually going to a different switches, and these switches can be are supposed to be cascaded. So in terms of switch redundancy, you actually cater for it. And those ports that's on the switch ports, they are actually facing ESX directly. What are the configurations? So you actually disable STP, or you actually enable port fast. This actually can be found in our VMware KB, which is actually listed. So there are also the ProCurve switches from HP. I think there's also a KB on it. So you can just do a search inside. So if you are using different kind of switches, we actually have certain KBs on how to actually configure them. All right. Okay. So next we'll talk about direct path I/O. So what is actually direct path I/O? So actually, direct path I/O allows the VM or the guest, which we call it, to direct access a network device. So it doesn't go through the virtualization layer. Okay, in short, what this can do is actually improve performance because you get a direct access to it. So you don't have the overheads that you have from the virtualization layer. So you reduce the latency, all right, from the high-speed network devices such as 10G. And you also isolate the network IOs only to one VM. So direct I/O is not actually required by most applications. So so far I have not actually came across any customer that I have that has direct I/O. So it will be based on your interviews with the customers or application owner if this is actually required. Unless there's a clear case for direct I/O, if not, it's best not to use it. Okay, based on current state analysis interviews that you can conduct. Right, so normally what direct IOs will be more applicable is to applications that has a high transactional workload. So it's more for transactional applications that really cannot suffer too much of a latency. They need as low as possible. But direct IO has its caveats, definitely. So for example, you have a 4-port network adapter. When you do a direct IO, you cannot specify which port, so the whole card is actually dedicated to that VM. And what happens to this is that when you do vMotions to other machines, each individual host will actually have to lose one PCI card just for the direct IOs. And yes, for vMotion is supported for VCAP5 for direct IO now, right? But also direct IO does not support certain features in vSphere. So example like fault tolerance is not supported. Okay.
Yeah, and the only justification for it was about the slightly greater receive latency on the paravirtualized NICs. The transmit latency is about the same, but the receive latency on direct path I/O will be lower than on any of our NICs.
Yes. Okay. Right. Next. Okay, so any other consideration? So use of FC over Ethernet, is it required or is it currently available? So should customer actually consolidate IP network? So in terms of fiber, all consolidate into IP for easier management? Is storage traffic via network a common point? So if you do consolidation all into a network switch, you can actually reduce the cables and NICs required. All right, in such you also reduce power and cooling because you reduce the amount for the FC switches, the SAN switches, and all writes onto your network switches. So single point of failure became very important, so redundancy has to be taken care of because now your storage and your network are all sharing the same type of switches. So it creates more important to create this redundancy. So the advantage is actually to connect the FC and Ethernet cable through the supported FCOE switches. And in short, you also use less PCI slots on the physical servers. All right. And I mentioned the switches, you have to create redundancy. So in terms of PCI slots on the physical server, you also have to cater for it.
Before we hit IPv6, we've got another question from the previous slide. Rio was asking about RSTP. Should this be enabled or disabled? I'm not familiar with RSTP.
Sorry, I didn't actually get that.
There we go. We've got Rapid Spanning Tree Protocol.
Oh, Rapid Spanning Tree Protocol. This one I couldn't, I don't have any information.
Well, Rapid Spanning Tree is a spanning tree protocol that instead of taking 90 seconds to converge, it's down to sort of 38 seconds. But the point is that the virtual switch in ESX has no impact on spanning tree, so there is no requirement for any spanning tree components, any spanning tree awareness on the ports that connect to the ESX server.
Yeah, so spending tree should actually be disabled. Yeah.
In all of its forms.
Yeah. If not, you actually create more latency, right? Yeah. Okay, good. Any more questions on that?
If you keep using the room questions, I can feed them into WeTech. I'm keeping those up in front of me.
Sure, sure. Okay, so we talked about IPv6. So there will be manageability, the management and monitor of the overheads that requires an IPv6. So IPv6 is still pretty new. Most of our environment, I'm not sure about other countries, but in Singapore it's starting to roll out. So most customer actually takes the chance here to actually refresh them to IPv6 if possible. Depends on applications. So whether their application can work or not. So what works and what don't, you see. So in terms of hardware, does it actually support IPv6? So in terms of VMware, we have VM kernels, our virtual machines, our vCenter server, our vSphere client, and all this is supported. But certain things like our syslog server is still on IPv4. All right, fault tolerance only support IPv4 as well. So what are the limitations that IPv6 is not supported? So example for the Broadcom cards, that the Broadcom iSCSI adapters or independent hardware iSCSI adapters, they are still not supportive of IPv6. And our vCenter server appliance that's available in vSphere5 is also not IPv6 supported at the moment.
And the fun thing on that is it's got the user interface to set an IPv6 IP address on the appliance, even though it's not supported.
Yes, yes, exactly. Yep. So the supporting tools like the syslog tools and stuff is also not at the moment supported. And of course, for the virtual machine, need card support as well. So in terms of planning for the IPv6, you have to take note of not only on the hardware, the virtualized environment components, as well as your software applications that do they actually support before you move everything to IPv6. Yep. Next. Okay, so on jumbo frame. So what we normally do for jumbo frames, we
Can I just hold you off for one moment? We have
Sure.
Karthik would like to ask a question about fiber channel over Ethernet. So I'm just unmuting Karthik if you'd like to ask your question.
Okay.
Are you there with a question?
No, I wasn't able to hear it.
Yeah, no, I haven't heard either. Karthik, are you with us?
I can't hear it though.
No, I'm not hearing anything either. Yeah, if we can't hear you, so do put your question up in the chat, and then I can in the question, like your jumbo frames question, and then we can ask it out. All right, well, let's carry on with jumbo frames, because that was another area that Karthik wanted to think about as well.
Okay, sure. Okay, for jumbo frames, so what do jumbo frames do? It actually can improve your frame rate, so you can actually send out more frames in a bigger frames, okay, in the pipeline. So normally we turn on jumbo frame in the storage layer. So if you are using IP storages like NFS, iSCSI, this actually improves the storage throughput. Okay, for VM layer, normally we will see if you have any requirements for this. Is it really required by application-wise? So for VM requirement for throughputs, it will more on the network design. You have to do it end-to-end supported. So for jumbo frame, for management network, it's actually supported. However, you need to make sure that end-to-end all levels must be enabled for jumbo frame. That will be including of your physical switches, your vSwitch, your port groups, your VM kernel, end-to-end, all the port groups, etc. You have to turn it on. If any of them was not configured to enable jumbo frames, then you will have some issues All right.
I've also come across one with a customer where, although the physical switches support jumbo frames, the stack cables that went into the back of the switches, so joining a pair of switches together into a stack, those stack cables didn't support jumbo frames, and the switch would actually silently fragment to pass across those stack cables. So even if you're doing path MTU detection, you wouldn't find that it was happening, but there would be fragmentation going on silently in the back. And that meant that jumbo frames in that particular scenario produce lower performance because of that particular behavior on that crossover, that stack cable. It's a very odd one.
Okay. So cables, yeah, that's one more thing. The stack cables has to be taken in consideration as well. Okay, so next we'll talk about the FT and HA redundancy. Is there a need for FT? HA definitely redundancy for management network. We want to cater for vSphere heartbeat HA, so network isolation for testing purposes. So for VM protected by FT, so FT logging require dedicated port group as well. So the FT logging network should also be redundant, all right, in case of failure. So for vSphere HA and FT configuration, all redundancy on the machine VM network should be catered for redundancy and availability. So in terms of there's no single point of failure when you want to do this design, wherever it's possible. All right. So in terms, if let's say if one of your NIC cards were to go down, you at least have the other ones still enabled, and this does not break your features in your HA and FT. Okay. So for direct I/O path, I think we mentioned it previously. So when you do it, you need to actually, there are only limited range of hardware. So when you actually implement direct I/O path, not just on the hardware itself, you must also make sure that your CPU support. For Intel processors, you have to support BTD supported and AMD for the VIs. So the processor must also support in order to have direct path I/O supported. So when you have direct path I/O, so you will not be able to have HA, FT, snapshot, hot add and remove, and also suspend and resume features on the vSphere area. Okay, for DNS server, definitely it's definitely required. If not, you have to specify the IP address, and I don't think anybody can remember that, right, by heart, for this, especially if your environment is not too big. All right, it should be configured to resolve the long and short name, definitely, and for the forward and reverse lookup, it has to be catered for the vSphere environment. So most of the components in the vSphere environment, like the ESX host, your vCenter, the additional modules of your vCenter, like update manager, not update manager, sorry, the other components that you could have purchased, like your chargeback applications, your vApps, your IP storages, all this should be configured with your DNS server to be able to be looked up. And it should be configured at a high availability server, all right, to prevent outage. So you should have redundancy for your DNS servers as well. Okay, next. All right, so now we touch on virtual standard switch. What are the pros and cons? So normally we'll refer to our maximum configuration guide. I don't remember VCAP exam actually tells you on that, just like the new VCP, we hardly touch on all these things now. So it's supposed to be a reference guide, so you are actually feel free to use it and refer to your reference guide, especially if you have many hosts and many connections. So you will have to take note of the maximum limitation, like the maximum port for each standard switch is actually 256, and the maximum network ports available for each virtual switches is actually 4088. And I don't memorize this, I actually take notes, I actually refers to the maximum guide as well. So alternatives, so we prone to error. So normally virtual standard switch, so if you have multiple ESX server, you have to configure every single one. And you cannot make a mistake, even just be one capital letter and the other one a small letter, your vMotion will not work. So this is very prone to human errors. These are the cons of it. configuration on every host is actually a lot of manual work, a lot of administration overheads. All right. So what you can use to minimize this is to use host profile to implement it. However, host profile is only available for Enterprise Plus editions for the vSphere. So in my implementation days for customer who does not have vSphere Enterprise and during your implementation time, because vSphere has a 60-day evaluation period. So during this 60-day evaluation period, you are actually given the Enterprise Plus features. So during the implementation, you can actually use host profile to help you deploy the machines out as fast as you can. And after the 60 days, then you key in your serial number. So in such, ease down your deployment. But after that, for scaling up, you will still have to do the manual way. Yeah. Next. Okay, so now we talk about distributed virtual switches. So the requirement for VDS, same thing. It is only available for Enterprise Plus edition of the vSphere. And the maximum configuration guide is something that I always strongly refer to. All right, and when you're planning for any design. Okay, so the maximum port, if you are to mix with VDS, it will be 4096 instead of 4088. And one VDS switch can actually support per vCenter of 30,000, and each vCenter can support more than 350. So, in terms of licensing, definitely as mentioned is Enterprise Plus license, and there's one crucial, it's dependent on vCenter to manage it. So if you are using VDS, you have to make sure that your vCenter has high availability catered on. HA must be enabled, and because what happens is that without VDS, when your vCenter, without vCenter, when you want to manage your distributed switch, it's not possible. If you go direct console using your vSphere client into each individual ESX server, you realize that you will not be able to see your virtual switches there, but you can't manage it at all. Okay. Next. Okay, another design consideration when we look is in terms of network separation. Do we need to separate the network? So different types of network, we are separating it because we want to reduce contention. And why reduce contention? Because it increase your latency, and this actually improve your performance when you separate the network. So different types of network is separated, like maybe backup and production. We don't normally mix this. So I'm just taking an extreme example. So this is something that we separate them. All right. So how do we separate them? Do we separate them into individual uplinks, and they are routed to different switches, or do we actually use VLANs? If we use VLANs, are they sharing the same trunk uplink? If they are, is there sufficient bandwidth? In terms of example, you mix production with backup. Are you using a 1 Gbps link or a 10 Gbps link? So if you are using a 1 Gbps link, when backup were to kick in, will production be affected? So teaming, are you using any teaming? All right. So if there's any failure, would there be enough bandwidth to cater after that? This is something we do look upon. So what about security? So is it in terms of security that you segregated the network? So network segregation, it could be because you're using IP storages, and for FT logging network sets, that's why you actually segregated the network. Or any other applications that you have that you require the workloads, and that's the reason why you have a separate network just for them. Then example is like your vMotion and IP storage. They are not encrypted. Yeah, many people are not aware. Your vMotion traffic is actually not encrypted, so you can actually sniff out the data. They are in plain text. So they are not encrypted, so a separate network will help protect what could be sensitive data, as I mentioned. And what you can do is on the network layer, how you can actually encrypt all this to take care of it. So you have to do your interview with the key stakeholders to determine what kind of workload and what kind of sensitivity they require. So in terms of SLA for the network in terms of latency and requirements, performance? Do they need to be secure? All right. So for components of vSphere, that is to create on a separate network, like VM kernel, the management network, our IP storages, heartbeat, FT. All you have to take note, this has to be placed on a separate network. Yeah. And if you are using 10GE for your vMotions, you do have to take note that the CPU cycle will be slightly higher. So this is also something that you have to take note of.
Hey, we're talking about segregation here on ports versus VLANs. Yeah. Do we have any particular recommendations? Is there any preference on that? That's a question from Sora.
Ports versus, again?
Whether to do the segregation by ports or by VLAN.
Okay. So there's no hard and fast rule, I would say that. It all depends on some companies. So certain companies do not allow sharing of data stream within the same uplink. So VLAN will be out, then you have to go by ports. That you have no choice. So VLANs actually help you reduce on the number of cables. So later we'll touch a bit of, more on the VLAN portion. But I'll answer this first. So it all depends on your company policy, whether they allow you to do VLAN and mix them, to trunk all the links together.
So it's existing security policy within the organization.
Yes. Yeah.
I had a couple of questions about distributed virtual switching configurations tied to around vCenter. So one of them I've just answered in chat, which was about the maximum number of distributed virtual switches and the configuration maximums guide, which of course is to say is not so useful for the exam, but still useful for doing the real job.
Yes, definitely.
32 distributed virtual switches per vCenter server is the 5.0 maximum, and 350 ESX servers per distributed virtual switch. I think there's a question about having more than one distributed switch attached to a data center. So a single ESX server can be attached to multiple distributed virtual switches, or a single distributed switch. So yeah, there's lots of flexibility about how many and where you use them.
Yes, definitely. Yeah. So you can actually attach you can create multiple distributed switch. Yeah. Okay, any more questions on that?
I think there's still a discussion I'm having with Adrian about spanning tree, and I think I'm getting into I'm describing things poorly on spanning tree. So we've been discussing about the content of the awesome Scott Lowe and Mesh Sadell Keesing and Forbes Guthrie's Designing vSphere book, which of course is another awesome reference for preparing for designing an implementation. Of course, that helps you to get ready for the exam. And I think I've been phrasing things poorly in my chat. We're definitely suggesting that you want the ports that connect to your ESX server to get through the process of thinking about spanning tree as fast as possible. And that's also, I think, the intent of what I read in Scott Lowe's book, which says on the storage network, you want as quick a recovery if a network cable comes out and goes back in again. If there's an interruption in that network, you want it to be as fast as possible for recovery, and you do that by having spanning tree port fast enabled. Now that means this port on my switch does not take part in spanning tree. It cannot be connected to another switch. Or alternately, if you don't have that option, then the rapid spanning tree, where it'll negotiate as quickly as it possibly can. The aim is to avoid that full 90 seconds of the port being blocked after the link is first attached that we get if you take a Cisco switch out of the box and plug something into it. That will be intrusive to your storage network.
Yes, I see.
Next question out of the floor, my good friend Nick Evans, asking about separation. If I'm limited on the number of network adapters of NICs that I've got, what sort of criteria should I use for choosing what to share? Like FT logging is suggested to be a dedicated network adapter and a standby. How bad would it be if I carried maybe management networking over that same physical NIC?
For the FT, actually it's quite loaded if you're using the FT logging. I wouldn't suggest you mix it with management. However, if you can put your FT to share with maybe 3 or 4 NICs together with the production, I think it's still fine. Because if management-wise, I will still, I mean, for my case, if I were to do the implementation, I would rather not share it with management because I will share management with vMotion because vMotion I don't use it often. So I'll do active standby and then standby active, sharing 2 NICs between management and vMotion, and try to mix FT with something that has a bigger bandwidth. Yep.
And
so
one of the things about FT is quite, although it's low bandwidth, it's quite critical. So you don't want to mix it with something non-critical and high bandwidth, like the high bandwidth vMotion. The other thing to bear in mind with FT and vMotion is that when a VM is being protected by FT, it starts by transferring memory contents across the vMotion network. It's probably not the right description for it, but it's very similar to actually having a vMotion begin and then not transfer execution, and that's when the FT relationship gets established. So setting up an FT relationship is going to push a lot of data across the vMotion network. So probably not good things to share together.
Yeah, so it's actually doing mirroring at real time. So data is constantly been transmitting over and synchronizing it. Yeah.
The other thing is a perception that management traffic is always lightweight, and that's not necessarily true. Whenever you are doing things like using the vSphere client to present an ISO to a VM, or if you're doing something like a cold migrate where a VM is being moved from one ESX server to another, if it's not sitting on shared storage, the whole VM gets copied across management network. So management network can be a very noisy network at times. Not regularly, but at times.
Yes, agreed.
Got another question out of the floor. Actually, 2 questions from Rio I missed earlier on. Enabling jumbo frames. Is there any risk around enabling jumbo frames? What can go wrong in an environment if you just blindly enable jumbo frames? After all, it is disabled by default.
Okay. For jumbo frames, if you do not actually enable them correctly end-to-end, you might get I'm not sure, but for myself, I actually encountered these connections on and off. The connections are not consistent. Yep, where one is able to transmit more frame while the other is not able to take in the frame rates. So you may have drop frames and things like that. So in terms of troubleshooting, it would be much more tougher because you have to just do it just not on the ESX layer, but also on the VM layer, the port group layer, the vSwitch layer, and then you follow on to your physical environment where your physical switch has to take in place and things like that. So yeah, unless needed, especially like for IP storages that you have, if not, I won't recommend you doing it unless the justification is there for you to use it. So
the question that was missed was enabling jumbo frames. Are there any issues? And the answer was yes. Enable only if you're going to benefit.
Yeah.
All right, we've got a couple more questions coming up as well. Are we going to hit on jumbo and flow control?
Flow control. All right. All right. For flow control, I don't actually have that covered, right? In my slides. Let me just have a look. Yep, I think I don't have it yet covered here. It's actually a way of managing your rate of data transmit between 2 nodes. It's more for troubleshooting, so I'm actually not covering this. For the new, vSphere 5, you have you have port mirroring and all this. So it's more for troubleshooting to identify the packets that be transmitted from one end to the other between 2 nodes. Yeah. And we actually have I/O control to do that, rather, in our vSphere feature.
Yeah, I think I've seen something somewhere and thought that would be interesting around enabling flow control. I think it was on 10 gig NICs, but I only have very vague recollection of having seen an issue somewhere.
Yeah, I don't actually have much also.
So I've got a note from Carlos saying jumbo frames flow control end to end.
Okay. I might have to get back on that.
So that was a flow control that's done at signaling level between the network adapter and the switch. and then the physical network adapter and switch, and then the same out, whatever the other end of that discussion is, like that communication.
Yep, I just did a quick search. Then we actually have a knowledge base regarding flow control, and it's actually on disabling flow control on physical network interfaces used by ESX and ESXi. Yeah.
Which kind of implies that it's a good idea to disable it for us.
Yeah.
Do you have the KB article number to hand, in case people are interested?
Yeah, I have it. Yeah, it's 1013413.
1013413. So if it's an issue for you, go and hit up the KB article. Okay, trying to clear down. As soon as we answer questions, we get more questions, which is an awesome thing. So reading down them. Carlos, who asked the flow control question, I'll give feedback on the flow control question, also had a comment really early on about with Cisco's UCS blade enclosures. It's really important to set correct QoS policies, and presumably that's the upstream ports coming out of the fabric extenders, and jumbo frames issues as well.
Yep.
Okay, sorry. Alexander has looked at the KB and says that by default, it says in the KB, by default, flow control is enabled on all network interfaces for VMware ESX and ESXi, and that this is the preferred configuration. If there are large numbers of pause frames in an environment, it might mean that there's an underlying issue that requires investigation. As always, KBs are our top reference. Our recollection of the issues is not necessarily right. We do our best.
I guess it gets two hands to clap, so you also have to check back to your vendors whether this should be enabled in a VMware environment, other than just looking at the VMware KBs.
Yeah. Got a couple of questions in around, I got one about 10 gig Ethernet. So about the classic issue of having moved from an environment, and I'm extending from what Rob Waite's asking, but the classic issue is that we've moved from an environment where the customer had 10 1 gig NICs in their ESX server, and they could carve them up and dedicate bandwidth at physical layer. They've upgraded to their new servers, and their new servers have two 10 gig Ethernet links in them. We got any recommendations about that? And in a related topic from Matt, any guidance for blades that use a virtualized 10 gig Ethernet? What kind of things go on with that? And he's particularly calling out the HPC 7000, but it equally applies in the Cisco UCS. You can get virtualized network adapters in there. Any suggestions around issues on those, all of those nice flash new 10 gig Ethernet adapters?
I don't have much information. I've not touched the two hardwares before. But for 10, I mean, if you have a bigger bandwidth, definitely it will be better. And I mean, if you have to be able to trunk all the networks together, it will be best. You have less cables and stuff, and all this can be taken care of. I'm not sure about the other two hardwares because I'm not read up much on them at the moment. Yeah.
So my feedback, particularly around that 210 gig E, is that's what network I/O control is all about, and I know we've got that coming on. That 210 gig Ethernets replacing lots of 1 gig is absolutely what I believe has driven network I/O control into existence, and we'll definitely be talking about that later on. The Flex stuff from HP has a whole heap of other issues around, and I think we need to go out and probably direct you to white papers from HP. They're pretty good at writing up best practices and then presumably rewriting them when they find the pain of those best practices, like any other best practice, and doing a new one. Are we going to look at multi-NIC vMotion? Because we've got a question in there about multi-NIC vMotion. If that's coming, then we can hit it then.
Okay. So multi-NIC vMotion, is that the question?
Yeah, so what are the design considerations?
You could actually use multi-NIC vMotion. That will, actually, I just got off my head. I actually read an article on that. I couldn't remember it by heart. Now, will the traffic actually go through two NICs?
Absolutely. Duncan Epping on yellow-bricks.com posted about this a while ago and
Yes,
said
yes,
it's
I
wonderful.
read about it as well. Yeah, it's wonderful. So you have more NICs, you can actually, the data will actually go through multiple NICs. So actually it brings down your time to vMotion, right?
Yeah, and also one of his important notes was that a single vMotion could travel across multiple NICs, and that's really unusual for VMware with networking. Most of the time, a single conversation, and a vMotion is a single conversation, only uses one NIC.
Yeah, exactly. So actually it will improve, but do you actually need multiple NICs for vMotion unless you're doing it so rapidly across your site? If there's no vMotion, there will be hardly any traffic going on in the vMotion vKernel port uplinks. So there's also a what you really want to achieve having too many uplinks just for vMotions.
Yeah, I think it's probably addressing the space where you've got those two 10-gig NICs that are being used for virtual machine and storage traffic, but you've got maybe a quad-port gigabit card that's not being used for anything else. You could use it as a way of getting relatively fast vMotion.
Yep.
Yep.
Right.
And guys, I love all of the URLs being posted in the chat, but I can't find a way, and the questions, I can't find a way to grab them out and reuse them in the notes. So I will see if I can grab, there's a whole heap of URLs coming in, so I'm going to see if I can get hold of them and get them into the notes for later on. So yeah, do keep them coming along with the questions. But we should probably let Wittek carry on because he's got more than one slide after this that we should probably let him get to because he's put the effort into making them together.
Yep. So let's move on to the next slide. Okay, use of standard switches and distributed switches, or should you use both? So why distributed switches? What are the benefits? As I mentioned, centralized management through vCenter. So using vCenter, you are able to manage your distributed switch. Consistency. Yes, consistency is one of them. So you do not have to go to individual ESX server and then configure every single standard switches in this case. And from distributed switch, what are the added advantage and functions that you get? You get private VLANs, traffic shaping, network IOs control, and all that. So in VSS, is it a requirement or is it a preference? So creating fewer virtual switch, preferably one. That's why you want the distributed switch. You can configure a single virtual switch with a port group for each type of network. That's for your standard switches. And one virtual switch with VLAN will work in an environment with limited numbers of physical network ports. So same thing when we refer to the maximum guide, you were to use many multiple standard switches. Will you exceed the maximum if you are doing it for the big environment? Yeah. So in a big environment, normally at minimum we try all to connect all the hosts that's enabled for HA and DRS to a single virtual switch. This why we do that. We want to possibly reduce the reconnect after migrations, right? And so in a design, when you want to include a single virtual switch, you can actually implement our VSU zone to actually inspect the segregated traffic in terms of security-wise. Yeah. So when you have a policy where you need to see VM to VM traffic to pass through a physical firewalls, right? Where the infrastructures need multiple virtual switches. Right. So the other way that to look at it is that sometimes you might want to put a standard switch to put your management LAN, management network to be on it, so that in terms when you lose your vCenter, you do not lose your management ability of your management switches. That's one way to look at it. Yeah. Next. Okay. So standard switches or on distributed switches for VM kernel ports. So the choice and you need to have justifications. The pros and cons. What happens when you don't have a vCenter and what you require for per host configuration. So vCenter became a single point of failure for VM kernel ports. It's not a single point of failure. So when you have distributed switches, you cannot manage without a vCenter. So whether to use standard or distributed switches, as I mentioned before, you might have you will still have to configure for VM kernel ports per host configurations. Yep. Whether you're on standard switches or you're on distributed switches, your VM kernel ports will still have to be configured. All right, per host. Every time a host joins to the environment, you still have to configure the VM kernel ports. So for virtual network, to move to a distributed switch or even place it to move your VM kernel port over to a distributed switch, you can actually consider when you use a Nexus 1000V. All right, to simplify troubleshooting, why we have it on a standard switch, to prevent connectivity issues. Right. So, for example, your VM networks, when you use your distributed switch or you move it to a Nexus 1000V, you keep your VM kernel ports on a standard switch. This actually helps you simplify your troubleshooting in terms of connectivity issue if there is one to arise. Okay, next. Okay. So, what kind of VNICs that we want to choose? So I actually put down the KB there. We will try to encourage you to use the latest and the latest VMX Next 3. Why to use this? In terms of performance, is the best. It is designed for performance. In fact, it's not related to VMX Next or VMX 2. What happens is that it offers all the features in VMX 2 and added additional functionalities like multi-queue, also known as receive side scaling in Windows for those network guys who are interested in this, and many other things like IPv6 offloads and MSIX interrupt delivery. So that is for VMX 3. So so you can refer to the KB for and also for this performance white paper, that technical paper on VMX 3. Okay, and use of split RX. So split RX is actually new in vSphere 5. It's only available. It uses physical CPU to process the network package. So if you to use split RX, this will increase your CPU cycles and also in exchange for improvement for your network performance for certain workloads. So multiple virtual machines on one ESX server. It's like the workloads actually includes the multiple machines that's on ESX servers. So split RX mode will actually typically improve the throughputs and CPU efficiencies. All right, and this feature is supported on only on VNX 3 adapters and is individually configured on each virtual NIC. All right, you have to set specialized variables. It's actually Ethernet X.EMU RX mode and individual virtual machine .vmx file. All right, so this is actually an advanced feature, so it's only configured if you really need them. Okay, the traffic is actually via network appliance API between two virtual machines, and it only works between two virtual machines on the same host. All right, it doesn't work across hosts, only within the same host. So you must see, if let's say you build your application and database server and you need them to talk with a very network increase in performance, then yes, you can use actually split RX on these two machines. And next we talk about network latency sensitivity applications. You can actually refer to the performance best practices for vSphere 5. So in this tech note, simple to put, we will actually recommend VMX Next 3 as much as possible. Disable power management in the BIOS and allow power management to manage your environment. Disable the C states in BIOS and enable turbo boost in your BIOS as well. Okay, and when using the VMX 3, you will actually disable the virtual interrupt co-scaling for the desired NIC. Okay, next. So the next we will talk about Microsoft load balancing, network load balancing. So this has been actually been discussed many times since VI 3.5, since I first exposed to VMware, and we always hit lots of problems. So our recommended is always using multicast if you have a customer using NLB. And the two articles that I actually pasted there, you can refer to them or let the customer have a look at them. And also refer to the guide, which is called Implementing Microsoft NLB in a Virtualized Environment. This is also found in VMware. So I just keep it simple. Unicast actually works very well in layer 2 switches and routers, but create a switch flooding when ports are not in the NLB are impacted. So what happens is that other ports that are not inside this network load balancing, they are impacted, they actually floods the switches. So network balancing cluster masks the cluster MAC address for all the outgoing traffic to prevent the switch from learning the MAC addresses. But when you use multicast, the multicast address is actually loaded to the added to the cluster. So the host actually retains their original MAC address and IP. So some routers do not support unicast to multicast MAC address conversions, and so they discard them. So in this case, you have to actually address it through adding in the static ARP entries to the routers. So unicast, you will actually need additional configuration on the ESX server. Right? So you can actually refer to the 2KBs for this. So I also, just now previously already mentioned, for the physical NICs in design, you will have to, whether to enable jumbo frames or not also depends on your physical NICs, whether they support or not. Okay, so I won't put too much on that, especially on the physical NICs, whether they actually support TCP segment offloads. Okay, next. Okay, next we talk about NIC teaming. So why do we want to do teaming? So normally we do teaming other than redundancy. We also want to increase the bandwidth available for the network. So it helps avoid single point of failure. That's also one thing. That's for redundancy purposes, or we call it availability. So in server consolidation, we normally compound the effect of failure. So we want to increase the redundancy. We set up NIC teaming by using the ports for multiple network interface. Right, so one port group will have multiple vNICs, which is actually tied to multiple physical NICs, and to reduce single point of failure. So as I mentioned previously, onboard and expansion, rather than having everything on board port groups, you actually have one on the port on board and one using expansions, right? So what's the requirements? You can have 2 or more NICs to set up a team, all right, on to the same physical switch that you can see in my first diagram. This is a very good design, and if it's best if you can even split it in 2 cascade switches, all right. So all the switch in the same port group broadcast in the layer 2. So between the 2 cascade physical switches, you actually created even a better redundancy. So you won't have not just NIC cards redundancy, but also switch physical switch redundancy is taken care of. Next. So on NIC teaming, for load balancing, there are several settings that you can set. We can route based on the virtual switch port ID. Virtual switch port ID is actually the ID from the VM NIC. Sorry for the spelling mistake. So this is actually the default configuration, where the traffic are consistently sent from the same physical adapter unless the physical adapter actually broke down. So how the switch, the original switch, virtual switch port ID works is that you will choose uplink based on the virtual port, and then the traffic will enter the virtual switch, which is the traffic will actually enter from the virtual Ethernet and go through the same physical adapter unless a failover were to take place. Then replies are received. So back and forth, the traffic will actually go through the same physical switch unless there's a failover. All right, and physical switch will actually learn the port association using the when you are using this virtual port ID. All right, so in terms of this, it actually provides even distribution of traffic. All right, given a virtual machine cannot use more than one physical Ethernet adapter, so multiple virtual machines will actually be using different physical adapters. So in terms of it, it has to spread out the loads of the traffic. Okay, so there will be slightly less load on the ESX server comparing than the MAC hash setting, which we will talk about it in the next, which is the next one. Okay, so just to take note, whether you are using source port ID or source MAC hash, you are to take note not to configure the physical switch ports of any type of teaming or bonded groups on the physical switches. So how source MAC hash work? It just work like the virtual switch port ID, but instead now it doesn't remember the port ID. Rather, it memorizes the VNIC Ethernet MAC address. All right. So these three policies. So the next we also have the based on physical NIC loads. So physical NIC loads will select uplink. Okay, this physical NIC loads only exist. If I remember correctly, is on only on virtual distributed switch. Yeah, and
Absolutely
the
is.
bandwidth limited to. Yeah, so the bandwidth is also limited to the physical NIC. So if your NIC only support 1 GE, it can only goes by 1 GE, right? If one were to get, the good thing about this physical NIC load balancing is that if one NIC were to get overloaded, it will actually pass over to the next one and use reassign the port NIC mapping to the next one, so that there will be a balanced status, right? So bandwidth is still limited to whatever the physical NICs can actually provide you.
But it's the point about load-based teaming is that it's the only NIC teaming policy we've got that looks at the load on the NICs, on the physical NICs, and makes the decision based on that. All of the other algorithms will ignore a problem that occurs when two busy conversations flood a single physical NIC when other physical NICs are unused. Have you seen load-based teaming deployed out? And this was a question from Carlos a little while ago.
No, I have not at the moment.
We do need to remember that that WeTech has only been with VMware for around a month, a little over a month now, so not too much out in deployment. And of course, my job as a trainer, I don't go out and spend time with customers deployed. I think load-based teaming should be deployed any time that you are choosing to use virtual switch port. Yeah, if you and you're not doing IP hash. I mean, there's also a comment out here that the IP hash based load teaming that you haven't yet gone to, NIC teaming, does increase the bandwidth available to each virtual machine.
Yes.
But not for any one conversation, and it doesn't avoid the noisy neighbor where one NIC is busy with two conversations when other NICs are not busy. So yeah, prior to load-based teaming, IP hash was a winner, but I'm sure you'll hit the other fun of IP hash teaming.
Yeah, so IP hash teaming, what happens is that the source and destination actually generate a hash value. So you actually choose the uplink based on the hash source and destination IP address on each packet and transmit it. So what happens is that the adapters within this team must be attached to the same switches, or at least a cascade switch. Yep, and your switch must support 802.380 teaming in order to have this. And of course, there's slightly more overheads. And as what Alastair has mentioned, the other three policy other than the NIC load balancing, they will actually require more loads in terms of the policy, because these are all randomly assigned. So in the random assign, whether within a fixed port or within a MAC hash, it could be by accident or actually match into one port, as what Alastair has mentioned. So physical NIC load balancing will be a good recommendation if you are on a distributed switch, and you can write on these features. Yeah. So the other configuration that you can choose is explicitly failover. So these are basically you can actually refer to the KB that I have listed at the lower right hand. So you can actually refer to about this load balancing teaming wise, and what are the pros and cons from this KB as well. All right. Next. So this is just a view on how you can actually, what are the available settings that you can actually use for the load-based theming. All right. This is under the settings that you can see when you select a distributed port group setting. Okay, next. So NIC theming availability. What we want to actually do is we want to reduce the number of network ports and maintain redundancy. So you could actually configure active-passive port configurations, and assuming that you have VLANs and trunk ports, so to meet the sufficient bandwidth. So the diagram actually shows you how this is done. Where the port group 1 you have 2 NICs, and port group 2 you have 2 NICs, and port group 1 is active and standby into port group 2, where port group 2 is active and standby on port group 1. It was a typo there. Alright, it's not port group 3, it's actually port group 1. So they are actually doing active passive. So you're actually sharing 4 NICs where they are actually doing active standby onto each other. Where the links, where the 4 links that are coming into the switches is all trunk. Okay, next.
Wojtek, I just realized we've rocked over an hour and 10 minutes in, and we're only 2/3 of the way through your slides. This has been really good. In particular, I've loved all the questions coming in and addressing those questions. Let's pick a logical moment to stop, and we'll schedule a time to cover the rest of the material, because I'm conscious that the time is rocking on, and we don't want to get too far into, get lost in the material. So let's find a logical place to stop in the next few slides.
All right. Okay.
We're on NIC theming, so we'll carry on with NIC theming.
Yeah, we'll just finish the NIC theming portion. All right. So for failure configurations, when to use link status only. Definitely you can use link status only when you have less than 3 NIC ports. So basically what it only detects the failures such as cable pull out and physical switch power failure, but it cannot detect configurations such as switch ports being blocked by spanning tree or misconfigurations of VLANs or cable pull out on the other side, which means the side that is behind the physical switches that is not facing the ESX server. So anything that is directly on or connected to the NIC port is only able to detect. Yep, so that's where we use link status. When you have more than 2 physical NICs used, we can use beacon probing. What beacon probing does is that it indicates a false failure. So if a switch is configured to block beacon probing, you have to actually make sure it doesn't do that. So there's a risk when beacon probing can indicate a false failure if a switch is configured to block a beacon packet. So you need to make sure that your beacon packet does not get blocked. So what beacon probing can do is that it can actually detect the uplink that's on the other side of the switches that could have gone down. All right, and which link status does not actually get it. All right, and beacon probing cannot detect upstream network failure. So to detect upstream network failure, you have to use a switch enable features like link state tracking available from Cisco, all right, or any switches that supports that. Okay, so limitation will be on the physical switch as well, and network failures. So it depends on which of it you are looking at. Then you have to configure respectively on the switch layer, or in terms of configuration wise, which to actually to be used. Next. So this is actually a table how what are the impacts of the load balancing policy for either on the 4 previously that we have talked about on the load balancing policy. So you can actually refer to this table in the summary. Okay. All right. I think that's the end for load back. Yeah.
That looks good.
Next will be on.
Yeah.
Sure.
So we will pick up again and carry on through the remaining third of the material, and it was absolutely awesome to have so many people asking questions and also posting up links to material. I will aggregate those links together. We'll get them posted up, and we might see if we can get these slides shared up as well. For me, the best thing about this session has been those questions and the answers, particularly such good answers coming